This lesson deals with supplemental problem 8.5. You can find this problem in the course ebook in the Chapter 8 Supplemental Problems on page 6. In this supplemental problem, we're going to make a sound level indicator. I'm going to add this to the circuit of supplemental problem 8.4, where we had our simple karaoke machine. The circuit consists of 3 comparators hooked up to 3 LEDs. This is a configuration of a non-inverting crossing detector, where I have a voltage coming in and I have a reference voltage at the minus terminals. We'll calculate those just shortly. If you recall, when the voltage at the plus terminal is greater than the minus terminal, the output goes high, approximately the power supply 15 volts, and current would want to flow out of the plus supply and turn on the LED. When the voltage at the minus terminal is greater than the voltage at the plus terminal, the output goes low and current would want to flow this way, but it can't. The diode blocks it, so the diode is off. The same is true for 2 and 1. Let's solve for the voltages at the minus terminals of the 3 comparators. All right, there's no current going into the comparator, so we have very high resistance. The current coming out of this 3-volt supply just goes straight through these 3 10K resistors. So we could use the voltage divider rule. Voltage reference 1 is going to be 10K divided by 10K plus 10K plus 10K times 3 volts. 10K divided by 30K times 3 is 1 volt. So this is equal to 1 volt. The voltage here is going to be 20K over 30K times 3, and that's going to be 2 volts. And of course, you have the 3-volt source right here. Comparator 1 is going to trip high whenever the voltage at the speaker is greater than 1 volt. For the yellow LED, when the voltage of the speaker is greater than 2 volts. And for the red LED, when the voltage of the speaker is greater than 3 volts. Now, as the voltage is increasing, the previous comparators are going to have a voltage that's greater than their turn-on voltage. So once the green LED comes on, it stays on. Once the yellow LED comes on, they both stay on, and eventually the red LED will go on. So as it gets louder, you see more LEDs lit. Now, what's going to be the value of the current in the LED? Right, when the comparator is high, we model it roughly as the power supply. And so current's going to flow in this direction. The voltage drop across the LED is going to be an ideal diode with the turn-on voltage V sub D on, and you can find the values for those different color LEDs in Chapter 9 on page 8. The rise in voltage would then equal the drop of the current in the LED times 1K plus VD on. So the current in the LED is going to be 15 minus the turn-on voltage for the LED divided by 1K. If our speaker voltage exceeded 1 volt, the green LED will light. The value will be 15 minus the drop across a green LED, which is typically 1.8 volts, and they give us 13.2 milliamps. We have a bright LED with that. Comparator for the yellow and the red LED doesn't have a voltage large enough to have the output go high, so the current is 0. As the voltage increases, as the sound increases, if we exceed 2 volts, then the green LED is on, because we're greater than 1 volt, but now the yellow LED would come on, and the current would be 15 minus the turn-on voltage, which is 1.7 for yellow LED divided by 1K. Again, gives us about 13 milliamps, more specifically 13.3 milliamps. So again, likewise, very bright LED. We don't have enough voltage to get the red LED to light, so it still has 0 current. And lastly, if the speaker voltage exceeds 3 volts, then the green will be on, the yellow will be on with the same values, and now the red will come on with 15 minus the drop across the LED, which is about 1.6, and give us 13.4 milliamps. This is how we can add a sound level indicator to our simple karaoke machine, and this is supplemental problem 8.5.